So let's do another example. If we take the derivative, f prime of x, we're going to get 2/3 x squared minus 4 to the negative 1/3 power times 2x using the chain rule. I want to set this equal to 0. Let's also simplify this so that it looks a little bit neater. So in my numerator, I'm going to get 4x. In my denominator, I'll have 3 and the cube root of x squared minus 4. So we're going to have a couple of things that we'll have to deal with here. First off, we need to figure out where the derivative is equal to 0. In order for this derivative to be equal to 0, it's just going to be the numerator. So I'll set the numerator equal to 0 and find out after dividing by 4 that x equals 0 is my critical number. I also want to find out where the derivative does not exist. So that means we're going to take our denominator and set it equal to 0. Dividing by 3 will give me just the cube root of x squared minus 4 equals 0. If I raise both sides to the 3rd power, my cube root goes away, and I get x squared minus 4 is equal to 0. X squared is equal to 4, which means that x is both positive and negative 2. So we're going to take both of these numbers and put them on our number line. Remember, we're going to label the number line. We're going to put negative 2 and positive 2 on the number line. And we're going, and also 0. Almost forgot 0. And so what we're going to do is we're going to test values here, 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 and here. And remember, we're plugging into the derivative, which is different from candidate's test. I think the easiest form of the derivative to plug into is probably this form. And so let's pick a number, like for example, let's make x equals negative 3. My numerator will be negative 12. My denominator negative 3 squared minus 4 would be 9 minus 4, which is 5. So that's going to be positive. So I'll have a negative number divided by a positive number, which will make that negative. And then I could pick another number, like maybe x equals negative 1. My numerator would be negative. My denominator, negative 1 squared minus 4, would be, 1 minus 4 would be negative. The cube root of a negative number will be negative. So you'll have a negative divided by a negative, which would be positive. And remember, I don't really care what the value is. I'm just thinking about negative divided by negative or positive or so on. We could test x equals 1. My numerator will be positive. In the denominator, cube root 1 squared minus 4. Denominator will be negative, so this will be negative. And then last but not least, x equals 2. We'd have 4 times 2, which would be positive. In the denominator, cube root of 2 squared minus 4. Not x equals 2. Can't pick 2. I don't know what I was thinking. How about 3? 3 squared minus 4, and this is going to be positive. So remember, you don't have to necessarily write out all of this work that's down here. That's just my notes and trying to show you where I get all of these numbers from. So now we can use this information to figure out what f is doing. So f negative would mean that f is decreasing. Positive would mean that f is increasing. Then it's going to decrease again, and then it's going to increase again. So let's answer some questions. I can now use my information to find out when f is increasing and decreasing. F is going to be increasing from negative 2 to 0, and again from 2 to infinity. F is going to be decreasing from negative infinity to negative 2, and again from 0 to 2. What's also nice is that I can clearly see my relative maxes and mins. I've got a relative min right here. I have a relative max right here. And then I have another relative min right here. And so we can actually name those. We can say we're going to have a relative min at -2 and some y value, and also at +2 and some y value. And our information has to include because f prime changes from negative to positive. Saying that f changes from decreasing to increasing is not sufficient. We're going to go ahead and also say that we'll have a relative max at 0 and some y value because f prime changes from positive to negative. And so we do actually need to go and find these y values, and you can find these y values right here by plugging into the original function. So if I plug into the original function, I can see that I'm going to get 0 here and 0 here. And this guy, when I plug in, should give me the cube root of 16, which isn't very pretty. Okay, so let's make a sketch of what we have going on here. I know that I have a point at -2, 0, another point at +2, 0, and then I have a point at 0 and the cube root of 16, which is a little bit less than 3. And I know that my graph is going to be decreasing, increasing, decreasing, and increasing again. And you might be wondering, Miss Lowry, why did you draw these with a cusp? I drew them with a cusp because I know that the derivative has to be undefined there. So I made them have some sort of sharp turn so that the derivative would be undefined. So that is all of our information for this graph. I want us to go through at least one more of these, and while I don't have time to necessarily do both, I thought we would at least do one of them. So I went ahead and chose to do this one, 1C, and if you want to do 1D a little bit later on your own, you can. I'm just not going to in the interest of time, okay? So to start with, we're going to take the derivative. This is going to require a quotient rule. So we're going to go low, D high, minus high, D low, ooh, almost messed that up. D low, draw the line, square the low, okay? So to simplify this, let's actually take out a 2x from the top. So I'm going to take out a 2x from this term, and that will leave me with 2x minus 1. And then I'm going to take out a 2x from this term, and that should leave me with just minus x. In the denominator, we'll still have 2x minus 1 squared. For a final simplified answer of 2x, and then I can simplify this stuff in here, 2x minus x will just be x minus 1. And then in the denominator, 2x minus 1 squared. And the reason we wanted to do that is because now I'm going to set this equal to 0. And so remember that there are two ways to get critical numbers. Number one, I can set the derivative equal to 0. That is only going to be your numerator, guys. That's just your numerator. So I can really easily see that I'm going to get x equals 0 and x equals 1 as critical numbers. I also want to find where the derivative does not exist. That is your denominator set equal to 0, which will just be 2x minus 1 equals 0, or eventually x is equal to 1/2. So it's important that you get this to a factorable simplified form so you can find all three of those critical numbers. So we're going to make our number line. Label your number line. We're going to put 0, 1/2, and 1 on this number line. Now, I actually want you to press pause, and I want you to plug into your derivative. Remember, you're plugging into your derivative. So the easiest form is obviously this guy right here to plug it into. And so pick some numbers in each one of these spots, here, 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 and here, and plug in. So if I plug in -1, I hope you can see that everything in the denominator, when you square it, will be positive. So the denominator is always going to be positive. If I plug in -1, I'm going to get a negative times a negative, which should give me a positive. If I plug in like a quarter, okay, if I plug in a quarter, the denominator is always going to be positive. I'm going to have a positive number times a negative number, which should be negative. If I plug in 3/4, denominator is going to be positive. I'll have a positive number times a negative number, which will be negative. And then if I plug in a number bigger than 1, like 2, denominator is positive, numerator is positive, and we should get positive. So what that tells me is f is going to increase, then decrease some more, and then increase. And I can see that I have a possible relative max right here. And I have a possible relative min right here. And nothing going on right here. Okay? So let's answer some questions. F is going to be increasing from -infinity to 0, and also from 1 to infinity. F is going to be decreasing from 0 to 1/2, and then from 1/2 to 1. Very important that you split these up, because at 1/2 it is not increasing or decreasing. We're also now going to talk about our relative max and mins. I have a relative max at 0 and some y value because f prime is changing from positive to negative. I have a relative min at 1 and some y value because f prime is changing from negative to positive. So let's find what those y values are, and I can do that by plugging into my original equation. So if I plug in 0, I'm going to get 0. If I plug in 1, my numerator is going to be 1. 2 times 1 is 2. 2 minus 1 is 1. So I'm going to get also 1. So let's make a graph. Let's see what's happening here. I know I have a point at 0, 0. I know I have a point at 1, 1. And what you may have missed that's happening here is there is a vertical asymptote at 1/2. You're like, how do you know that, Miss Lowry? Take a look at this guy right here. You have a vertical asymptote at x equals positive 1/2. And so let's look at what's happening. I know that my function is supposed to increase and then decrease. And then it's supposed to decrease some more and then increase. And this actually is one that's got a slant asymptote, but I'm not worried about you making that sketch. That's exactly what's happening here, and there is some sort of slant asymptote since it's bigger on top. So what I'd like to finish with in this video is doing some application-based questions. So we're going to use this graph of f prime. And anytime you get a graph, you always want to look at your graph and decide, what is this the graph of? Be careful. What is this the graph of? So this is the graph of f prime. So I want to identify the intervals. on which the graph of f is increasing or decreasing. And so remember, if f prime is positive, f is increasing. If f prime is negative, then f is decreasing. So I'm going to grab my highlighter, and don't look at what this graph is doing. I just want you to look at negative y value, negative y value, positive y value, positive y value. Because remember, this is the graph of f prime. So I can now answer part A. I can see that f prime is positive on the interval from -3 to 1, and also from 4 to infinity. That means f is increasing on the interval from -3 to 1 and from 4 to infinity. And this is this is totally weird on your mind because you're looking at what this graph is doing, but I don't care about whether this graph is increasing or decreasing. What I care about is this a positive value of f prime or a negative value of f prime? Similarly, f prime is negative on the interval from -infinity to -3, and then also from 1 to 4. So that tells me that f is going to be decreasing on the interval from -infinity to -3, and also from 1 to 4. And so remember, now I can figure out where is the value going to have a relative maximum or minimum. Now, you're not going to actually be able to find these values, but you will be able to estimate where it's going to have them. So if I look at -3, notice that at x equals 3, f prime changes from negative to positive. So f prime goes from negative to positive. That means that f is going to go from decreasing to increasing, which means at x equals 3, there is a relative min. So there is a relative min at x equals -3, and we're going to say because f prime changes from negative to positive. And then I can see right here, 1, something else is going on. At 1, it looks like we're going from f prime is going from a positive value to a negative value, which means that f is going to go from increasing to decreasing, means that there is a relative max at x equals 1 because f prime changes from